Fused deposition modeling. Introduction. The technology was first developed by Scott Kemp in 1988 and the patent was awarded in the US in 1992. FDM is also is known as material extrusion additive manufacturing technique utilizes polymer as a raw material. Liquefier head extruder nozzle part support foam base build platform material spool build material spool. Principle of FDM. The main principle of FDM is based on surface chemistry, thermal energy, and layer manufacturing technology. The material in filament spool form is melted in a specially designed head which extrudes on the model as is extruded. It is cooled and thus solidifies to form the model. Build material. There are various material used in FDM. Polylactic acid (PLA) is the most adopted material by most 3D printer users at domestic and industrial level. Other material used in FDM process including PCl, PP and PE and PVT, ABS, nylon metal, carbon fiber, graphene, doped PLA, etc. Support material. The support material is a removable polymer used to support the build material, especially when complex geometries are being built. These structures are broken away from the final part during post-processing. SR35 used with ABS EST7, ASA and ABS M30 and ABS M30I. Extrusion head. The extrusion head is essential part of FDM process. It performs three of the most important functions. The extrusion head pulls the material from the spool, melts them, and accurately places them onto the build platform within a two-dimensional plane. Build material spool. Support material spool. Liquefier head that moves in X and Y direction. Drive wheel. Heating filament. Extrusion nozzle. Build material. Foam base. Support material and build platform moves in Z direction. Build chamber or build platform. The temperature controlled area instantly solidifies the melted thermoplastic as they are being laid onto the build platform. This platform moves vertically in the Z direction, starting close to the extrusion head and slowly moving downward as the FDM process progresses. FDM process explained with the block diagram. Model designing, slicing and generating G code, printing and post processing if required. FDM process. First pre-processing. The use of computer and computer aided design CAD to create a visual 3D model. There are several CAD tools that are used to generate 3D model, of which include AutoCAD, Inventor, SolidWorks, CATIA, and so many others. The slicing software transforms the 3D design into layered model which the machine tool can easily trace. There are many slicing software and they are provided under different trademark names such as Cura, Prusa, Slicer, Matter, Matter Control, Simplify, 3D, Repetier, Idea Maker, Jet Suit, Slicer, Ice SL, Slicer Crafter, Astro Print, 3D Printer OS, Self CAD, Slicer, Tinkerine Suite, NetFab standard including other, and each of the software operates differently to achieve the best slicing. The extrusion head heat up to the appropriate temperature. When thermally stable, the head pulls the build material and support material from their perspective storage spool. These thermoplastic filament melt at the extrusion head and deposit as a bed being laid onto the build platform. The thermoplastic solidifies almost instantly upon entering the temperature controlled build chamber, which builds the part layer by layer from bottom to top. As the extrusion had finished depositing material, the build chamber and build platform remain mechanically and thermally stable. These allow the build part and support structure to settle and cure with proper microstructures. As after this cooling state, the support structure are broken away and the final build part is cleaned. Advantage of FDM: fabrication of functional part. A FDM process is able to fabricate prototype with material that are similar to that of the actual molded product. It is able to fabricate fully functional part that are have 85% of the strength of the actual molded part. This is especially used in developing product that require quick prototype for functional testing. Minimal wastage. FDM process built part directly by extruding semi-liquid melt on the platform. Thus, only those materials needed to build the part and its support are needed. Ease of support. Removal support is structure generated during the FDM build building process can be easily broken off or simply washed away. Build materials supplied in spool form are easy to handle and can be changed readily when the material in the system are running low. This kept the operation of the machine simple and maintenance relatively easy. Disadvantage: restricted accuracy. Part built with FDM process usually have restricted accuracy due to the shape of the material used. Typically, the filament used has a diameter of 1.27 mm, and this tends to set a limit on how accurately the part can be built. Unpredictable shrinkage. As the FDM process extrudes the build material from its extrusion head and cools them rapidly on deposition stresses induced by such rapid cooling invariably are introduced into the model. Slow process. The building process is slow as the whole cross sectional area needs to be filled with the building material. Building speed is restricted by extrusion rate or for the flow rate of the build material from the extrusion head. As the build material used are plastics and their viscosities and are relatively high. The build process cannot be easily speed up. Application of FDM prototypes for design. analysis and functional testing, pattern and master first tooling, model of conceptualization and presentation, medical industry, prosthetic leg, artificial teeth, food industry in food preparation to apply item in liquid or paste form such as cheese, icing and chocolate. Architectural industry, artists can create model of their projects. Art, automotive and aviation industries, automotive and aviation uses 3D printer to make body part. Would be the first prototype car 20 2011 was presented. This is the first car ever had its entire body printed onto the giant 3D printer. It has 3 billion 2 seats.